Welcome to PIQ'S TV. This is another lesson under General Chemistry 2. This is your host, Dr. Glenn Michael Jameson Pitero. Our topic here is all about nuclear chemistry. Today, we're diving into the intriguing world of nuclear chemistry, which deals with the reactions and properties of atomic nuclei. This field plays a crucial role in energy production, medicine, and even understanding our cosmos or the universe. First, let's just review some concepts, especially with regards to the structure of an atom. At the center is the nucleus composed of protons and neutrons surrounded by electrons in orbitals. Nuclear chemistry focuses on the nucleus and its changes during reactions. What are the types of radioactive decay? Atoms, as was discussed earlier, can undergo transformations by emitting radiation, a process called radioactive decay. There are actually three main types of radioactive decay: the alpha decay, the emission of a helium nuclei; the beta decay, the conversion of a neutron into a proton or vice versa; and lastly, the gamma decay or the emission of high-energy photons. Let's now provide an example of balancing nuclear equations. So in our previous lessons, we have discussed balancing equations. There is also a special type of balancing involving nuclear equations. For example, we have uranium-238. If it undergoes alpha decay, it will become another element. So it would be now 234 thorium plus the alpha decay, which it pertains to a helium atom. So how will you describe this particular nuclear equation? Uranium-238 decays into thorium-234 and an alpha particle designated as a helium atom. Now have a simple problem solving problem involving the half-life or the decay. There's actually a specific formula for more complicated problems here. For the half-life, it's T is equal to n sub 0 1 half raised to the t over t halves for the half-life. Quantity remaining n sub 0 is the initial quantity or the original quantity. T is the elapsed time. T halves or the half-life of the substance. For example, the problem reads, calculate the half-life of a sample. If a 100 milligram sample of radium-226 decays to 25 milligrams in 3,200 years, how can we calculate the half-life? The half-life is calculated by recognizing the amount halves every half-life period. So, starting from the original sample here, 100 milligrams, it can be a thought problem solving experiment here. You can try to imagine it through using your brain. 100 milligrams, it's the first half-life will produce 50 milligrams and the second half-life would be 25 milligrams. So actually in this particular problem, you can say that two half-lives occur in 3,200 years and one half-life is equivalent to 1,600 years. Well, let's now have nuclear fission and fusion. There are actually two fundamental reactions here, namely what was said earlier, nuclear fission and fusion. Fission is where a heavy nucleus splits into lighter nuclei, common in nuclear reactors or nuclear power plants, while fusion is when the light nuclei combine to form heavier nuclei, which powers the sun and different stars. Both processes releases enormous amounts of energy. Nuclear chemistry has vast applications. First, its use in medical imaging and cancer treatment, energy production by nuclear power, and even in archaeological dating using carbon-14, one of the isotopes of carbon. In summary, nuclear chemistry is not just a field for scientists in laboratory but affects many aspects of our lives from healthcare to energy and beyond. The study of atomic nuclei opens up a world of possibilities for innovation and understanding our natural world. Okay, we are now at the end of our video lesson. Just like our previous video lessons, we have our own exit cards. Just write the things or conclusions about what you have learned about the topic and also what questions are you going to ask the teacher. You can post this in the comment section of our YouTube video. Laging tandaan, sa PIQ'S TV, panalo ang natuto.